Hey, what's up, Chem Peeps? Let's take a look at an example problem in which you're using a heating curve. Calculate the total heat energy in joules needed to convert 20 grams of substance X from negative 10 degrees Celsius to 70 degrees Celsius using the heating curve and the information provided. All right, let's take a look at this heating curve. We're thinking about 20 grams of this substance initially at negative 10 degrees Celsius. And we want to know how much heat is required to get the 20 grams up to 70 degrees Celsius. First calculation, I need to think about how much heat is required to go from negative 10 up to my melting point of 5 degrees Celsius. It's a sloping section, so I'm going to use MCAT. Boom. My mass, 20 grams. The specific heat in the solid phase, 2.0 joules per gram degree Celsius. And the temperature change, final temperature 5 degrees, initial temperature negative 10 degrees. That's a temperature change of 15 degrees Celsius. Quick jump to the calculator. 20 times 2 times 15 is the amount of heat required to heat up our solid from negative 10 to a solid at 5 degrees Celsius, 600 joules. I'm going to remind myself of 2 sig figs just by putting a little line there. Segment 1, 600 joules. Next, I need to complete a phase change, go from the solid to the liquid phase. I'm at a plateau region here, so I'm not using MCAT, I'm going to use the molar heat of fusion. Now, as I take a look at this, oftentimes this molar heat of fusion is telling us how much heat is required per mole. But notice that the heat of fusion is given to us in joules per gram, which is convenient because I'm already provided with the amount of my substance in grams. So it's just going to be 20 grams times that molar heat of fusion, which is 100 joules per gram. Calculator. 20 times 100 is the amount of heat required to completely melt my solid, 2,000 joules. Remind myself of sig figs. Segment 2, 2,000 joules. Next, segment 3. We're going to heat up our liquid from 5 degrees Celsius to 55 degrees Celsius. Once again, we're going to use MCAT. Boom. Mass, 20 grams. Specific heat of the substance in the liquid phase, 5.0 joules per gram degrees Celsius. So notice the specific heat is different depending on the phase that you're in. My temperature change, I'm going up to 55 degrees Celsius from a temperature of 5 degrees Celsius, delta T, 50 degrees Celsius. Calculator. 20 times 5 times 50 is the amount of heat required. 5,000 joules. 5,000 joules. Next, phase change. We're going from the liquid to the gas phase. How much energy is required to do that? Don't have a temperature change here. We're going to use the molar heat of vaporization. Lucky enough for us, again, the heat of vaporization is provided in joules per gram. 20 grams of our substance, heat of vaporization, 1,000 joules per gram. 20 times 1,000. How much heat is required? 20,000 joules. Segment 4, 20,000. That brings us finally heating up that vapor to an even hotter vapor. Sloping segment, once again, we'll use MCAT. Our 20 grams is now all in the gas phase. The specific heat in the gas phase, 1.0 joules per gram degree Celsius. Times our temperature change, we're going up to 70 degrees Celsius from 55. Temperature change of 15 degrees Celsius. Calculator. 20 times 1 times 15 takes 300 joules worth of heat energy to increase our gas from 55 Celsius to 70 Celsius. All right, final moment of truth. We want the total amount of energy. How much heat was required to completely cause our 20 grams of substance X to go from negative 10 Celsius in the solid phase up to 7 degrees Celsius in the vapor phase. 600 plus 2,000 plus 5,000 plus 20,000 plus 300. Enter. 2 significant figures. Now we're adding least precise place value is the 1,000s place, so my answer 28,000 joules. Boom, we are done.